In the Northwest Territories of northern Canada, winter can turn vast lakes into temporary roads. On the Tibbitt-Contwoyto Winter Road, heavy trucks can travel hundreds of kilometers through remote wilderness, with sections of the route running directly across frozen lakes. But look closely at what lies beneath the wheels. Not concrete, not asphalt, just a layer of ice, with water still lying directly beneath it. A truck weighing dozens of tons is sitting on it. All that weight is carried by the tires, while only a layer of ice separates the truck from the lake below. So how thick and strong does the ice have to be to turn a lake into a road for this truck? And if it is strong enough to support dozens of tons, why can't drivers simply travel as fast as they would on a normal road? The Tibbitt-Contwoyto Winter Road begins at Tibbitt Lake, about 60 kilometers east of Yellowknife, and stretches hundreds of kilometers north through the Northwest Territories. Much of the route passes through remote wilderness, where vast lakes and open stretches of land lie between supply points and distant mining areas. In winter, those same frozen lakes open up a route that simply does not exist during the warmer months. Trucks begin heading north, carrying fuel, food, supplies, and equipment needed for mining operations at the end of the route. And these are not isolated trips. Throughout the shipping season, trucks repeatedly carry supplies in and then turn back, making room for the next loads to move north. For the drivers, those hundreds of kilometers also mean hours on a route where they cannot simply stop wherever they want in the middle of the wilderness. They have to follow speed and spacing requirements and stop only in designated areas. Those rest points therefore become important places to eat, rest, and prepare for the next leg of the journey. At the end of the route, the cargo is unloaded to support mining operations. Then the truck turns around, another one heads in, and the trucks keep moving like this until the ice is no longer in a condition that allows the route to remain open. That is what makes an ice road different from an ordinary road. It does not exist year-round. It appears only during a period when the lakes are cold enough, the ice is strong enough, and supplies still need to be brought in. But every one of those trips depends on something directly beneath the wheels, a layer of ice that has to support dozens of tons of weight. So what allows this layer of ice to support trucks weighing dozens of tons? A truck weighing dozens of tons is sitting in the middle of a lake, with its entire weight being transferred onto the layer of ice directly above the water. On a normal road, the load is ultimately transferred into the ground or a structure built to carry it. On an ice road, the ice itself has to take on that role, while a vast body of water still lies directly beneath it. So what allows a layer of ice to support that much weight? The first factor is thickness. As the ice becomes thick enough, it can carry greater loads and resist bending under the weight of a truck. But thickness is not the whole story. A very thick layer of ice with poor structure does not necessarily carry loads the same way as ice that is clear, dense, and relatively uniform. Ice can contain air bubbles, snow, or areas with different internal structures, and these features affect its ability to carry weight. So even if a lake looks flat and solid from above, that alone is not enough to tell whether a truck can safely cross it. That is why the ice has to be inspected directly. Crews can drill through the surface to measure its thickness and examine the condition of the ice below before determining how much load a section of the route can safely support. When the truck puts its wheels onto the ice, its weight is transferred through the tires into a broader area of the ice rather than being concentrated at a single point. The surrounding ice, therefore, also helps carry the load, but it can still bend under the weight of the truck. So a layer of ice that is thick enough and has the right structure can support a very large load, even with water directly beneath it. But ice is not a rigid, unchanging road surface. It still responds to what is happening above and below it. And when the truck starts moving, that relationship becomes more complicated. The load is no longer acting at one fixed location. It shifts as the wheels move forward, while the ice and the water beneath it continue to respond to the truck's movement. So if a stationary truck and a moving truck do not create the same loading conditions in the ice, What happens as the truck's speed increases? When the truck starts moving, everything changes. When the truck is stationary, its weight creates a relatively stable load on the ice. But once it starts moving, that load continuously shifts across the ice, while water still lies directly beneath it. And this is where things get interesting. Ice is not an absolutely rigid slab of concrete. Under the truck's weight, it can bend slightly, and as the load moves, the area of ice being affected also continually shifts with the truck's position. Under certain conditions, the truck's movement can also create waves in the water beneath the ice. At that point, the truck is not simply pressing down on a fixed layer of ice. Its movement is also affecting the entire ice and water system below it. This makes speed an important factor. As speed increases, the effects caused by the truck's movement can also become more significant. A truck being heavy enough to sit safely on the ice does not mean it can travel at any speed. On the Tibbitt-Contwoyto Winter Road, drivers must follow the speed and spacing limits set for operating conditions. A truck weighing dozens of tons cannot simply see a flat road ahead and decide that it can drive as fast as it would on asphalt. The distance between trucks also matters. When multiple trucks are traveling on the same ice road, spacing helps prevent several heavy loads from acting on the same area at the same time. So drivers have to control not only their own trucks, but also their speed and distance from other vehicles. From inside the cab, the road ahead may look completely flat and quiet, but beneath the wheels, the ice is still carrying the load, while the water below can still respond to the truck's movement. That is why, on an ice road, driving faster is not simply a matter of getting there sooner. But before drivers can travel across the lake in the first place, a crew has to turn that layer of ice into a usable road. So how do they do it? And why is one of the first things they have to do clearing snow from the lake? Before a truck can put its wheels onto the lake, the ice has to reach a thickness and conditions suitable for the loads the route will carry. But what is surprising is that the process of creating this road can sometimes begin with something that sounds completely backward: clearing snow from the lake. Snow covering a lake is not just a white layer sitting on top of the ice. It also acts as insulation and slows the lake's heat loss, causing the ice beneath it to grow more slowly. So, under the right conditions, crews can clear snow from areas where they need the ice to grow. Once the snow is removed, the lake loses heat more quickly, allowing the ice beneath it to continue thickening. From the outside, this looks almost nothing like building a road. There are no rollers laying asphalt, no concrete being poured, and no permanent road surface being placed on the lake. People are simply creating the conditions for the ice itself to grow into a road surface. Over the course of several weeks of winter, the ice continues to thicken. Areas that initially were just water, covered by a thin layer of ice, gradually become sections that can be surveyed, inspected, and prepared for trucks. But even then, the trucks still cannot simply start driving. A lake that looks flat and white from above does not reveal exactly how thick the ice is underneath. In some places, the ice may be thick and strong, while other areas can have different conditions because of water movement, snow, or the way the ice formed. So the crews building the route have to work directly on the lake, checking each area to determine which sections are ready and which still need further preparation. They can drill through the ice to measure its thickness and check its actual condition below the surface. Each measurement helps determine whether a section of the lake is ready to become part of the road. And this process does not happen at just one location. As the route crosses multiple lakes and different types of terrain, each area has to be inspected and prepared before it can be put into use. That is why an ice road is not simply a matter of waiting for the lake to freeze and then sending the trucks across. Crews have to monitor the formation of the ice, alter the surface when necessary, check its condition, and only put each section into service once it meets the required standards. In other words, they are not building a road on the lake. They are growing a layer of ice strong enough to become the road. Once the sections meet the requirements, the route is prepared for use. From this point on, the frozen lake is no longer just a body of water covered by winter ice. It becomes a road for trucks carrying supplies through remote territory. But unlike a normal road, this route still rests on a layer of ice that continues to change. Temperatures change, the water beneath it changes, and the trucks themselves continually affect the ice as they travel across it. And sometimes, that change appears right on the road surface as a crack. If a crack appears on a section of the road where trucks are already traveling, how do they know when it is simply a change in the ice and when it is actually a problem? A crack appearing on the surface of the ice does not mean the entire road immediately becomes dangerous. Some cracks form as the ice contracts or changes with temperature, but what matters is knowing where the crack is, how it formed, and what condition the ice is in around that area. A visible crack on the surface, by itself, cannot tell you whether the ice underneath can still safely support a load. If a crack appears in an area currently carrying the weight of heavy trucks, route managers have to assess it more carefully. The area may need to be inspected to determine the condition of the ice and whether the route is still suitable for the loads currently allowed to travel on it. And in the meantime, trucks may still be out on the route. Drivers still have to follow the established limits, maintain an appropriate speed, and keep their distance from the trucks ahead. They cannot simply decide that a section that still looks solid means they can drive faster or move closer to the vehicle in front. Spacing becomes especially important when multiple trucks are using the same section of ice road. The trucks are kept apart to prevent several heavy loads from acting on the same area of ice at the same time. So a convoy can be moving according to plan, but a single abnormal sign in the ice can cause the entire flow of the convoy to change. If an inspection shows that a section of the road no longer meets safety requirements, operations in that area may be restricted or stopped. In that situation, a driver cannot simply speed up and get through the area as quickly as possible. The truck has to stop and wait for a decision on whether the route can continue to be used. And this is when a problem in the ice begins to affect more than just one driver. Behind the waiting truck, other vehicles may still be carrying fuel, food, and equipment toward the end of the route. If a section is restricted, the trucks behind it may also have to wait, change their schedules, or temporarily stop moving supplies. A crack, therefore, does not necessarily destroy the road, but it can slow down the entire supply chain that depends on it. On a normal road, a small crack might simply be a problem with the road surface that can be repaired later. On an ice road, the road surface itself is the layer of ice floating over water. So a small sign on the surface can force people to stop, inspect the ice, and decide whether dozens of tons of weight can still be allowed to pass. And if a route can have its speed limits or load limits reduced, or even be temporarily shut down when conditions change, why do trucks weighing dozens of tons still have to travel this route every winter? The answer lies at the end of the route. These trucks are not traveling hundreds of kilometers across the ice simply to overcome a winter challenge. Each trip serves mining operations located far from regular roads, where supplies still have to be delivered during the coldest months. On the Tibbitt-Contwoyto Winter Road, trucks can carry fuel, food, supplies, and equipment needed for mining operations. These materials have to reach their destination so the mines can continue operating through the winter. Imagine a truck leaving the Yellowknife area and heading north. Its cargo has already been prepared and loaded. The truck travels across ice roads, frozen lakes, and vast stretches of land, with hundreds of kilometers still remaining before it reaches its destination. Throughout the journey, the truck is not simply traveling from point A to point B. It has to deliver the right amount of supplies to the right place, because there is no network of stores or large warehouses at the end of the route where missing supplies can easily be replaced. When the truck reaches the mining area, it stops, and the cargo begins to be unloaded. Fuel is moved into storage or used for mining operations. Food and supplies are delivered to the areas where they are needed. Large equipment is taken off the truck and put to use at the site. This is where the entire long journey finally takes on meaning. The supplies that have just been unloaded are no longer sitting on a truck in the wilderness. They become fuel for machinery, materials for the worksite, and essential supplies for operations at the end of the route. Once the delivery is complete, the truck does not stay there. It turns back along the same route it just traveled, while other trucks continue leaving the supply point with the next loads. And this is the important part. One truck carries a single load, but over the course of a winter, there can be hundreds or even thousands of trips following one after another. Each trip brings more fuel, more food, more supplies, or more equipment to the end of the route. Seen this way, an ice road is more than a frozen surface for trucks to drive across. It becomes a seasonal supply route, with cargo constantly moving in and trucks constantly returning to prepare for the next trip. But the time available for this supply chain is not unlimited. The shipping season lasts only as long as the route can remain operational, which means a huge amount of supplies has to reach the end of the route before winter comes to an end. And that entire system can operate only as long as winter keeps the route in usable condition. But if a road is important enough to carry thousands of loads across the ice, why not build a permanent road so trucks can travel there year-round? If you look at the map, the answer may seem simple at first. Just build a permanent road connecting the supply areas to the mines, and the trucks would no longer have to depend on winter. But when you look more closely at the route, the problem becomes very different. The road has to cross enormous distances and pass through terrain where building permanent infrastructure is far from easy. And the route does not cross land alone. Vast lakes lie between the places that need to be connected. In winter, these lakes freeze and become part of the route. If the entire journey were to become a year-round road, the sections crossing these lakes would require permanent structures so vehicles could pass through in every season. But building those structures would only be the beginning. A permanent road would also have to be maintained, repaired, and kept operational for years, even in areas that are extremely remote and have almost no infrastructure around them. That is where an ice road has a very different advantage. Winter has already turned these lakes into temporary road sections without requiring a permanent road to be built across them. Crews only need to take advantage of the period when the ice reaches suitable conditions, connect the land-based sections to the frozen lakes, and use the route during the shipping season. So a road that exists for only a few months can sometimes make more sense than a road that has to operate year-round. Not because an ice road is better than a permanent road, but because it uses the conditions created by winter itself to provide a temporary transportation route. But the very thing that gives an ice road its advantage also creates its limitation. The road exists only as long as winter allows it to. When the ice conditions no longer meet the requirements, the shipping season ends and the route is closed. There is no permanent road across the lake to dismantle. When the ice melts, the ice road sections on the lakes disappear on their own. The areas where trucks once moved one after another begin to fall silent, and the people who worked along the route gradually leave the frozen wilderness. But the road is still there. There is no crew sent in to dismantle it. No machinery has to tear up the road, and there are no sections of concrete or asphalt to haul away. The road simply disappears. As temperatures rise, the ice begins to weaken and gradually melt. Tire tracks fade from the surface, and sections once used to transport supplies gradually return to being lakes and waterways. From above, the transformation becomes even clearer. Where trucks once traveled one after another, there is no longer a visible road, only open water and the remaining ice as it melts away. And what makes this road unusual is that people do not have to tear it down. Winter creates it, and the warmer season erases it on its own. When the next winter arrives, the cycle begins again. The water freezes, the ice gradually thickens, and winter roads once again appear across the same waters that were used the previous season. A road like this is not built to last forever. It appears when winter allows it, serves transportation needs for a limited period, and then disappears when conditions are no longer suitable. At the beginning of this story, we saw a truck weighing dozens of tons sitting in the middle of a lake, and the question was how the ice could possibly support it. By the end of the season, the story reverses itself. The truck leaves, the ice disappears, and the lake returns to what it was, as if there had never been a road there at all.